Hey, what's up everyone? Welcome to Profit Data. So today exactly I'm going to talk about this quantitative finance, predicting stock prices and trading strategies in Python. I've been already done 3 videos on this particular topic. Okay, so please go ahead and watch that video. Okay, so we will gonna start where we left off. Okay, so we'll start with the derivative. In math value dependent on that we'll get an output value. Okay, so derivative are a fundamental tool of calculus. For example, the derivative of the position of a moving object with respect to time is the object's velocity. This measures how quickly the position of the object changes when the time advances. Okay, so right now, so we will definitely gonna understand what is derivative and differential calculus. Mainly the sole purpose of this will be like getting into slope and moving further to our topics. Okay, especially it will be like machine learning and artificial intelligence. Okay, so we will try to touch as many as segments as much as possible. Okay, so these are the say suppose if robots are there. Okay, and if you want to communicate with them and want to make understand our language and want to uh, give them directions for a particular work, so mathematics is very much important, especially like quantitative finance for trading strategies. It will be very much helpful. Okay, so please do understand and let's go for these things. Okay, so I have been already told you. So some of the things which we take so suppose if we take a graph. Okay, so suppose if we are taking a graph, now what happens here, and y and x axis will be there. Okay, which I already told you. Okay, now if I can take this example as an velocity. Okay, so whatever my car has been moved, this can be taken as an velocity, and this will be t equals time. Okay, so this is my v as a velocity and t as a time. Now this we can consider. So this is our example, which is like a definite example is a default example. Say if you go with anything, they talk about car, they talk about speed, acceleration, jerk, each and everything. So what we gonna take from the velocity, we can take as in price. Okay, so for our consideration, this will be for velocity, it will be in a price. So we are considering the price, and time will be the same for this, for price or velocity or anything time dependent, we are doing the same. So this is how we are doing. Okay, so this is the consideration which you need to take. So if I talk about this for example, the derivative of the position of a moving object with respect to time is the object's velocity. So to measure these things, I am doing this particular taking consideration of a moving object with respect to time and velocity. Exactly, I am measuring okay how quickly the position of the object changes. So in my case, the price and time will be there. Okay, so now the important part, the derivative of a function of a single variable at a chosen input value when it exists is a slope of the tangent line to the graph of the function at that point. Okay, so whatever say talk about, see this is our what we are talking. So in geometry, the tangent line to a plane curve at a given point is a straight line that just touches the curve at that point. Okay, so any point like say suppose if we got this point. Okay, so suppose here we need to check what is the tan. Okay, say suppose I'll say what is the trend here. For me it is very much required, the trend is very much required. Okay, so I'm gonna talk whether it is positive or negative. Okay, I already talked about this steepness, like higher and whether it is upward or downward or something like that. Okay, if it is moving towards positive, it will be steep, will be on a higher side, and steep, like if you're getting downwards, steep will be on a lower side. So we'll get to know about plus and minus. So that's how we required. So if we need to decide the trend, how we'll go. If it is moving upwards, then the trend is in positive, so we'll go for buy. And if it is like getting in a minus, okay, so if it is getting downwards, we will go for the sell. Okay, so we decide the trend through this particular part, and we get to know. And how the calculation will be dependent, it will be dependent on the time. Okay, we take the particular time as well. Okay, so suppose time period is 5. Okay, as we take in different moving averages, I already talked about, like 5 windows we will take, say 1 plus 2 plus 3 plus 4 plus 5, and divide by 5. Okay, so we'll calculate that particular thing with the n number, which will be equivalent to 5, and we divide this thing particular 5. So same as with these things, we take a particular time, this one. So suppose if I got the value as in 4 points my market, like 4 points the market has been increased. Okay, like you consider 4 big size as we take in a Renko graph. Okay, so 4 rupees has been increased. So if I take this as in 4 rupees and my time periods, like I've been done calculation whether it's 2 minute or 2 days data, so my slope will be 2 rupees. So how I've been done, it is very much simple here. Okay, but there is a calculation is there which we are going for, this will be kind of a big bang theory where exactly a smaller point will be there, but we need to define all those things, because if we need to go for some derivative rules, and to get this derivative rules it is very much important. Say it is very much easy. Say 4 by 2 means 4 rupees, 4 will be my price, so I will say y by x, and y by x means price by time, delta price by delta time. Okay, so whatever change in p by change in time, so that's how we are going. So delta p by delta means like delta t. So 4 rupees of my price, 4 points have been increased within 2 periods of time, so my slope will be 2 rupees. So it is positive, so I am going for this particular point. Say suppose I got minus in a negative trend, so say suppose my Renko chart is in negative. Okay, I'm getting downwards, and same period I've been took, so now my slope will be -3. So my trend is in negative, so I go for the sell, and I will go for the buy. Okay, so particular trend which you can decide, and a price which you can put on. Okay, so we can consider this 0. So if it is above 0 we are going for buy, and if it is below 0 we are going for the sell. Okay, so this is how we are going for particular segment. So this is very much necessary to understand these things, because particular this computer understand particular calculation. So we need to put all those things which will calculate instantaneously, and it will be very much fast. So for that purpose we definitely require this stuff. Okay, so let's move on. So especially the Jacobian matrix is a matrix that represents this linear transformation. Okay, so linear, I've been already talked about this linear approximation. So if I talk about linear transformation in mathematics, and more specifically in linear algebra, a linear map is a mapping V gives W between two vector spaces that preserves the operations of vector addition and scalar multiplication. Okay, so if we relate those things, and if we get in touch with, we get to know about what other things are there. Okay, so we can explore further. So if some chemical reaction, if we mix this hydrogen plus oxygen, 2 hydrogen plus oxygen. Okay, so that's how H2O gets formed, and we get the water. So that's how we will take some of the independent variables, and we try to take it out with each other, and we get to know some particular point. Okay, so we can decide from certain points, certain values, we can decide further things. Okay, so this is very much required. We will definitely wanna move further and explain this particular point. Okay, now if I say talk about slope, so I already talked, like slope will be represented as m, and we say change in y by change in x, so it will be delta y by delta x. Now if I change in, so we change in y, change in x, so that's we represent the delta, so delta y by x. Now y by x will be our sine by cos x. Okay, sin x by cos x will be tan x. So that's how we get the tangent. Okay, so that's how we get to know about, and this will be, so this is this is the calculation. Say if I already told you, this will be Cartesian plane will be there, y and x, and this we will say slope tangent line, we will definitely gonna say, so slope or tangent line. Now the calculation will get to this one. So our previous value will be on lower side, say x1 y1. So you already know, if you move to this certain points, and if you are getting to the upper points, it will be a lower value and it will be upper value. So that's, it is very much easy to decide. So if I say y2 minus y1, say here y2, say y1 will be there. So if I subtract 4 minus 2, so that's how we get. So you say here it is 2. So that's how we get to know. So it is very much easy to calculate this linear functions, and whatever we decide, we are taking this as an y and x. So it will be an opposite, adjacent, same as with this hypotenuse. So that's how we say this is a whatever we decide this slope. Okay, especially if I say this is the point which we need to consider, and I get to know what is the derivative of a function, or whatever we have been, say suppose this will be input, and I want to know about this derivative, what is the slope here. Okay, so that's how we calculate. Okay, so that's how we move. Okay, So you go, say suppose this will be your tangent line will be there, and say suppose particular x is there, so you want to differentiate. Okay, so this is the tangent line which we consider as a slope. So if a slope will be there, how slow, so you know the slope formula, so you need to differentiate. So f of x will be there, so you need to differentiate. So if you get to know about differentiation of x, that will be a slope. Okay, that will be the point of that derivative. So that's how we get to derive and get to know. So first of all, whatever you decide, say suppose price you decide. Okay, so if you get to know about some x value here, okay, so this is the starting point and this will be the ending point. Okay, now you get to know about this slope, what is the slope of that one. So here we can't decide, okay, because we need to move here further, and this is definitely not a tangent line, this is a secant line. So that's how we decide. So we'll take x, okay, then f of x plus h. So there is a calculation is there, so we know we'll move x plus h to this part, x approximation means we get to approximation which is tends to 0 when this is zoom in type of concept. So whatever we try to take it from here, it will be zoom it here, then we'll get to know about this slope. Okay, so this is how we particularly move this segment one by one by deriving one by one. So this is prime, we'll derive first, we'll take the value of this point and then we'll derive further. So this, as you can see, this secant line, it's getting a tangent line. So previously you can see the colors of this part, okay, is exactly getting to a tangent line. When it is approached to 0, tends to 0, okay, approximation, then exactly we got the slope of the tangent line, we got a derivative of a function. Okay, so that's how we go. And this particular example is there. So formula we know, this is our formula. Okay, especially we will go for this one. In limit which when we say h tends to 0, means say suppose this is h will be there. So suppose if we are taking a point, okay, from here the secant line gets to tangent line, and only it gets to tangent line when it is approaching to 0, and when we reach 0 we got our slope of a tangent line. So that's how we decide. Okay, which will be not easy, but you can calculate. Now if I say, so suppose if I am talking about a formula, so if I take f of a plus h minus f of a by h, now h will be in a 0 value, h tends to 0. So if you are reaching, h will be 0. So suppose we'll take the formula, we will say h tends to 0. Now f of x, it will be x square. Now it is very much simple. If you know the derivative rule, x square, so it is a power rule. Okay, x to the power n, so we'll say nx to the power n minus 1. So 2x to the power 2 minus 1 will be x to the power 1, so it will be considered as an x, 2x. If I say x equals 3, so if I say 2 into 3 will be 6, so you get to know that the value will be 6. Okay, but if you don't know the derivative rule, you have to go through this complexity. X tends to 0, we'll get a slope, tangent line, we'll get a tangent line. Okay, now this is how we are doing. Say x square will be there, so this is a parabola. Okay, x square will be there. Now a point is there, from point I am reaching to this part, so that's how I am reaching. I am calculating a plus b to the whole square, squaring up, okay, and then cancelling out. So I've been utilized so many things. Okay, say I already talk about these things. Say if I say the square function given as this one, okay, differential at x equals 3 and its derivative there is 6. Okay, this result is established by calculating the limit as h approaches 0 of the difference coefficient of f of 3. So if you follow this stuff, you definitely get to know what I am doing right now. So from a point, from a secant line, I am getting to a tangent line. From a point to a point, I've been calculated, and I'm moving from h, and when it tends to 0, so I'm changing, and continuous change, I get this value. So now I get to know what is the slope or derivative of a function. That point, what is the speed of my car, or what is the point of a given graph, or say that chart or particular point, how much point I've been gained. Okay, so that's how we consider this stuff. So this is the parabola, this is the parabola graph where exactly we get to know. So if I say x square, this is the approaches will be there. Okay, so that's how we go to take f of x and differentiate. Okay, if you know the derivative rules, it will be very much easy to derive. Okay, so if I talked about x, say sine of x square plus 1, so 1 will be 0. Now if I say derivative rule. So this will be in a product rule which we need to be considered, and then chain rule is also there. So if I take as an x as an constant, so I will say x, then I will say cos into x square into 2x. 2x will be this one, okay, and then we say plus, and we will go for further, then we will say 1 into sine of x square. So that's how the differentiation follows, okay. So here they have been already told, okay, sine of x square will be there. So x will be, you can derive in another way as well. So I've been already told you. So x square means it will be 2x, and one more x will be constant. So I will say 2x square. Okay. For sine we will get to know that it is cos. Okay. So this is how if we consider this as an price or say chart, so whichever the point is moving right now, so the value whichever you put, okay, so whatever f dash, whatever the point you consideration will be there. So for our x and y value will be on this particular point, okay. Even we can say as a cosine and sine, this is like as I say, this you can go for the cos and sine as well if it is in radian or degree. But for this particular, this is a Cartesian plane, so I will say x and y value, okay. Especially we are going for the x and y value itself, okay. So if you have particular 2.2, so if x consideration is somewhere point, so the slope of the tangent will be varies in this way, okay. So whatever with the considerations will be y by x, so that's how we are going for this particular point. So we're definitely gonna take it and try to derive this so this is the derivative rule. So if I already talked about e to the power x and even log x y by x, so e to the power x will be differential will be the same, that is e to the power x, but while deriving log x it will be y by x, and I already shown you the graph of these things. So if I say sin x, the derivative will be cos x, and if I say cos x, it will be minus sin x, okay, and tan x will be this, and you can write sin by cos x itself, okay, and differentiation will be secant square x, okay, and inverse is this. And for sine of inverse 1 by root 1 minus x square, cos inverse minus 1 by root 1 minus x square, and tan inverse x will be 1 by 1 plus x square. So this way, say suppose if something is in degree and you need to require this length, okay, instead of angle, okay, so this is the required conversion is required. So some formula is there, so derivative rule is there which you can go for it, okay. So I will say you can follow differentiations rules, okay. So we'll check this differentiation rules, okay, and we follow further steps. So product rule will be there, and power rule, product rule, okay. So this is how we get to know power rule, product rule, quotient rule, and chain rule will be there, and this is the calculation where we get to know about. So you can follow the differentiation rules and we can get to know about. So this is how mainly we are considering. We are already done with our complex numbers, so we are dealing only with the real numbers, and say suppose if we are including both real and imaginary, so complex numbers is very much required, okay. So product rule formula will be there. So derivative rules if you follow, then you need not to follow this complex formula, okay. You need not to go for this one. So we're definitely going to talk about this x square. So let's take this x square itself, okay. So I've been already shown how you can plot and how you can take this stuff, okay. So we'll straight away try to take this plot itself, okay. So let's see. So if you need to define x square, means it will be you need to define as in this way, okay. So this is how you differentiate. So this is the parabola which is we are talking about. So if I say x square, this is how the graph is we get to know, okay. And the differentiation, say if I define this, if we differentiate this particular, it will be 2x. So right now we are trying to following this power rule, okay. So how we get to know about this power rule? So here the power rule is there. Okay, so if I say x to the power n, so it will be nx to the power n minus 1. So this is how we follow. So instead of that complexity, if we follow this one, it will be very much easy to calculate. So if I say x square, so this is 2. So if I say r, 2x to then power to the power 2 minus 1. Okay, so if I say suppose power rule will be there. Okay, so power rule, what say power rule says x to the power n, if it is there, so any power, it can be 1 2 3 4 5, it can be anything. So if it is x square or parabola graph, okay, if it says x square, so what is our formula, what is our derivative rule for our power rule? It will be nx to the power n minus 1. Okay, so what is our n? It will be n equals 2. So 2x to the power 2 minus 1, okay, which will be 2x to the power 1, which will be same as 2x. Okay, so that's how we are going for this particular plot. Okay, so that's how we get to know. So same as with these things, if I say talked about x cube, okay, and differentiation will be on this particular plot. Okay, so it will be like 3x square. Okay, so n will be nx to the power n minus 1. 3 minus 1 will be 2. So that's how we get to know. I'll show you in further in a good format. Okay, so just for the plot I will show you right now. Okay, so first we will try with our plot with a simple plot, which is x cube, and what will be the differentiation I'm gonna show you right now. So x cube, if I say x cube will be our plot. Okay, so this will be our graph will be there. Okay, it is approaching this way. Okay, now if I say if I differentiate, we will get to about parabola. Okay, so we differentiate this stuff and we'll see. Okay, so this is how our x cube, and if I say x square means differentiation, this is our differentiation of x cube. So we whatever the approach we have been seen earlier, it is getting downwards. Okay, especially, but in case of when we say 3 into x square, so it is 3 times of x square. Okay, so that's how we tends to changes. So this is the derivative of an x cube. Okay, x cube will be, so this is how we get to x square, so 3 times of x square. So that's how we get to know. So this is the changes which we need to consider. So this is the derivative of a function. Okay, so whatever, say suppose I'll run once again. Okay, so right now when we are say considering this point, okay, say when we getting 3 times of x square, okay, present, say suppose I've been started my tangent line and I'm moving. So what it is moving, like whatever I've been done, which tends to move here. Okay, so suppose x square is there, I'm particularly considering the x graph. Same as with this derivative function, when it is getting tends to means like in getting a negative, same format will be in an approaches towards upwards. So it is getting down and down. Okay, so that's how the approach has been seen in a parabola. Okay, so if I particular consider this point as in C, this is like concave down. Same as with these things, this is the approach when we consider this parabola 3 into x square. That's how we moving. Okay, so you need to consider. Further we will go for further stuff and all. I've been already done with sin x and cos x. Okay, we will explain further. Good, same plot we'll see for our even for sin x and cos x as well. Okay, so we'll take the plot for sin x, and then we will go for the plot which will be cos x. Okay, and we will try to plot differentiation of sin x. Okay, so we'll try to see what we are doing. So this is our sin x. Okay, how we can say this is tends to be from start from the 0. Okay, so now if I plot, say suppose my sin x derivative will be cos x, so how I'm gonna say? So if it is the tangent line, when I consider this here a tangent line, okay, now I am tends to approaching 1. Okay, so if I say the slope of the tangent line will be 1, okay, then I am getting a tangent line 0. Okay, so that's how the approach will be there. So that it will be approach to 1. Okay, this is the approach from here up to this, the approach will be 1, and then it's get downwards. Okay, so from the approach 1 will be there and we'll get to downwards. Okay, we'll move to the downwards. Okay, same as with this approach, and when it is tends to be positive, so here we initiated and we will see in cos x. Okay, so as you get to know, the whenever we have been approached sin x from here, okay, now our cos x derivative will be 1. Okay, same as with these things. So wherever, say suppose if it is a sin x and I got here, say suppose it tends to in a downwards, so it is getting in a downwards. So same complexity, say suppose if it is rising and here I got some value upon this one, so this will be and vice versa of that one. So that's how we consider. So this is our range. So this will be cos x. So differentiation. Okay, so sin x differentiation, so cos x plot we got. So differentiation will be in this way. Okay, so that's how we decide. So particular segment, when we get at first approach, okay, then derivative of that function will be on same that approach. Okay, so that's how we initially move and derive particular segment. Okay, some x cube will be there, we get to like x cube from 3x square. Okay, so it tends to be derivative of a function, so I get to know about that slope at that point. Okay, so suppose if I am considering a stock chart, so I get to know at that point what is the point, whether it, and I should know whether it is upwards or downwards, whether it is positive or negative, whether I should go for buy or sell. So that's the reason for my consideration for derivative. That's why I'm explaining this stuff, and further also I'll take in a linear regression, and so many things is upcoming in my videos. It is available. For right now I'll wind it up here, and in my next video I will definitely gonna discuss about different differentiation rules. Okay, so I must say thanks for watching. Please do like, share and subscribe. If you have any other queries or requirements, please do contact me direct via WhatsApp. Thank you.